Welcome back, guys. For today's little mini lesson here, we're going to review the concepts of free fall. We're going to so the first one, Moops drops a baseball from the top of a 35-meter high building. How long will it take to fall, and how fast is it moving right before it hits the ground? And I always think pictures help. So we're going to draw a little picture here. We have actually, let me use a different color. We have a displacement of negative 35 meters. And we're trying to figure out how fast the ball is going right before it hits the ground and how long it takes. So I can see that right here. How long would it take? That's a time. And how fast is it moving right before it hits the ground? So those are my two question marks. So I need two answers. I do know a couple more things that aren't explicitly stated in numbers. One, I know that A is negative 10. And the reason I know that is because it is falling. And for anything falling, acceleration is going to be 10. And I also know one more thing, because it is dropped, I know the initial velocity is 0. Because as soon as Moops takes his fingers off of the ball will, like if you think about it in slow motion, the ball starts at rest and then starts to fall. Okay, so first off, I'm going to look at my equations and figure out kind of what I have and what I can use. I think, well, I could use a couple. But I'm going to start with this one. And the reason I'm starting with this one is because I have a distance. And so because I have a distance or a displacement, I know I'm going to use one of my displacement equations. I'm going to use this one because the other one has a VF, and my VF is unknown. So if I do that, actually the other equation has a VF and a T, and I have question marks for both of those, so I can't use the other one. So this equation that I have right here, this equation has distance, which I have. It has a VI, which I have, and it has a T, which is what I'm looking for. So let's plug in our numbers. So I get VI times T plus 1/2 negative 10T squared. Okay, that just goes away. So I get negative 35 equals negative 5T squared. I can divide both sides by negative 5, and I get negative 7 equals T squared. And then I take the square root, and the square root, negative 35 and negative 5, that's going to make a positive 7. And then I get T equals 2.65 seconds. So that is one of my answers. That's my answer that I'm looking for right there. Once I have this, I can use almost any equation to find my VF. I'm going to use, it doesn't matter which one you use, you'll get the same answer. The simplest one to me looks like this one. So I'm going to say VF equals VI, which is 0, plus negative 10 times T, and this is my T right here. So I'm going to plug that in. So VF would equal negative 26.5 meters per second. So those are my two answers. It makes sense that it's negative because the ball is going down. So it's going to be negative. All right, let's try another one. Moops throws a rock straight down from a helicopter at a velocity of 22 meters per second. Okay. So we're going to start with a helicopter. I'm not going to try to draw a helicopter. I'm just going to say Moops is up here, though. We'll say the ground is down here. And he throws the ball down at... So this time we have an initial velocity. Actually, let me highlight it. We have... This is how fast he throws the ball. So this is our starting velocity because he throws it. This is different than dropping it. So if he drops it, then VI is 0. Because he throws it, then VI is 22. And once again, he's kind of in a helicopter, but I'm not going to draw the helicopter. We have 4 seconds later. And we're trying to figure out what is the rock's displacement? Oh, velocity and displacement. So we're trying to figure out the final velocity, and we're trying to figure out the displacement. Because it's falling, I know A is -10, and I see one more thing I need to fix. It says down at 22. So mathematically, if I want to write down at 22, I can't write 22. I need to write it at -22 because it's going down at 22. Okay, so I got everything. Let me write some equations. So for the first one, I have VI, T, A, and I'm trying to find VF. So I'm going to use this one. Let's use green. I'm going to use this one. Okay, so I get -22. Oh, sorry. This is my question mark. So I get VF equals -22 plus -10 times 4. Well, that seems pretty easy. I get -22 minus 40, which is a final velocity of -60, not 2, -60. Yeah, there we go. Okay. Awesome. And then I want to try to find the displacement. So I have VI, I have T, I have A. So I'm going to use the other equation. I'm going to use this one. Okay. So I have a VI. I have a T. I have a 1/2 A T squared. All right, this is just straight math. I can solve this pretty easily. I get -88 minus 5 because half of -10 is -5. And I'm going to do 4 squared is 16. So then I get delta x is -88 minus 80, which is -168. And it makes sense this is -2 because I'm measuring the distance down. So it's -168 meters. Awesome. If you are in Physics in the Universe, this is going to be the end of the video. If you're in Honors Physics and you want to see some more difficult examples, we're going to do those right here. So this time, instead of throwing straight down, we're going to throw up. And throwing up increases the complexity. Oops. Okay, so we got a cliff. It is 40 meters high. So our displacement is -40 because we're measuring it down. He throws it up at 25 meters per second. So that's from the top of the cliff up. And we want to find what is the total time. So we're looking for t. We want to know the velocity of the ball right before it hits the ground. So that's going to be down here. This is our final velocity. So we're trying to find VF. And we want to find the maximum height. So we're trying to find, I'll write it as H max. All right. What do I do? So to start with, let's do the time first. So to find the time, we are going to use this equation right here. We're going to use delta x equals VIT plus 1/2 AT squared. And the reason I'm using this one is because I have the displacement, I have the initial velocity, and I have A. So I have delta x, VI, I don't have T, but I have A. So I have all of those. So let's see. I would have negative 40 equals, oops, pin's not working. Let me try that again. 25t plus 1/2 A, which is negative 10t squared. So I see I have a t and a t squared here. I see I'm going to get a quadratic. I could think about, could I use another equation? Maybe I could use another one that won't give me a quadratic. So if I use this one, I can't use this one because I don't have T and I don't have VF. So I can't use that one. And the other ones, this one, that one I could use. I have VI, I have A, I have X. That would give me the final velocity. So the equation I'm using will work. Let's try using this one. It looks a little easier than solving a quadratic. So let's put this one on hold, and let's go to the other one. Okay. I mean, we might have to go back to our quadratic, but let's see what happens here. Okay, VF squared equals VI, which is 25 squared, plus 2 times negative 10 times negative 40. All right, this looks pretty simple. 25 squared is 625 minus 5 times negative 400. So this would be VF squared would equal 625 plus 2,000. So VF squared would be 2,625. I'm going to take the square root of both. So the square root of 2,625 equals 51.23. Remember, this is plus or minus because I'm taking the square root. And I want to focus on the negative one as the one I want because it is going down. My final velocity right here is down. So I'm going to make that. Okay. That actually helps me a lot because now that I have VF, I can use this one. So if I put negative 51.23 equals my initial velocity, I can find the time. So let's do that. 25 minus, I just wrote the same thing twice. That's okay. Let's subtract 25 from both sides. So 51.23. We get negative 76.23 equals negative 10t. I can divide both sides by negative 10. And I get a time of 7.623 seconds. That was much easier than what I put on hold over here. This would have given me the same answer for the time. I could have solved for t. I could have got the same answer, but I didn't have to do a quadratic this way. I just had to find VF first, and then I used the other equation to find the t. Both ways work. This way it saved me from a quadratic. All right, so I have my time, I have my VF, I need maximum height. So for this one, I'm going to look at this part right here. I'm going to look at going from here to the top. So from there to the top, I have a starting velocity of 25. When it gets to the top, I know my velocity is 0. And I want to find this distance. So I'm going to use this one again. So I'm going to say 0 equals 25 squared plus 2 times negative 10 delta x. I get 625 minus 20. I can subtract 625 from both sides. I get minus 625 equals negative 20 delta x. Divide both sides by negative 20. And I get delta x is 31.25 meters. So remember, this is this green height right here, 31.25 meters. It's this up part. To find the total height of the ball, I have to add this down part, which is 40. So my total height, my x max, would equal 31.25 plus 40, which is 71.25 meters. So there are several ways to do these problems. You can use a multitude of equations. It's just kind of whatever one floats your boat and makes the most sense for you. This video is going kind of long, but we're going to do one more example. All right. Meeps is standing on a 60-meter high cliff, throws the ball straight up. So let's draw our picture again. We have 60 meters. She throws it straight up. And this time we have a time. 14 seconds. And we want to know the final velocity, the initial velocity, and the maximum height. So we're looking for the initial, the final, and the maximum height. Okay, we did one like this in class before, but let's give it a shot. So let's think. What do I have? I I have a delta x and a t. So I know I'm going to need an equation with a delta x and a t. So I'm going to use this one. Let's see. Can I use this one? I have a delta x. I don't know my VI. I have a t. I have an a. I have a t. So I can use this to find VI. So let's do it. So my VI. So I would have negative 60 because it's going down. VI times t. Oops. Plus 1/2 negative 10 t squared. So I get negative 60 equals 14 VI minus half of 10 is negative 5. And then 14 squared is 196. Okay, so I get negative 60 equals 14 VI minus 980. Add 980 to both sides. So I get 16.33 equals 14 VI, and I can divide both sides by 14, and I get VI equals 1.17 meters per second. Does it make sense that it's positive? Yes. She's throwing it up, so I can actually write that, what I found right here, 1.17 meters per second. It's not very fast. Okay. So now I need VF. So I can use a multitude of equations again. I'm going to use this one. So VF is 1.17 plus negative 10, and I know the time is 14 seconds. So VF would be 1.17 minus 140. Okay, so VF would be negative 138.83 meters per second. Okay. Let's keep going. So I got VI, I got VF, I need maximum height. So I'm going to do the same trick I did before. I'm going to look at the maximum height from here going up. Oops. So to do that, I'm going to go the up height. My VI is 1.17. My VF at the top, my pin's not writing well. VF is 0. Okay, so I'm trying to find the distance. So I'm going to use my pen is not writing. VF squared equals VI squared plus 2 delta x. So I get 0 equals 1.17 squared plus 2 minus 10 delta x. 0 equals 1.17 squared. Oh, sorry, yeah, 1.37 minus 20 delta x. I'm going to subtract it. So I get this. Divide by -20. Doesn't go very high. Okay, so once again, this height is just from, it's just this one right here. It's the up height. So I need to add the down height. So my total height, so my X max would be 0.0685 plus 60, which is 60.0685. All right, so I got my X max, I got my VF, and I got my VI. I am good to go. All right, hopefully this is making a little more sense. If not, please ask some questions, and I will see you guys